So last time we actually did open up Android Studio last time, right? We started doing stuff. Did I actually run it in the emulator or anything?
No, no.
Yeah, I didn't remember where we stopped off. Okay.
You just should have installed it.
Oh, okay. So we never even created an application.
Correct.
So, okay. So let's go through that. That'll kind of take you through a little hello world thing you would have done. So once you have Android Studio installed and updated, actually mine's still not updated. At some point I'll hit that button, but it's updated enough. It's the same version you have, just minus a bug fix here and there or something. So you'll start a new Android Studio project. And we can call this guy whatever we want. We'll call this guy CSC250. Maybe, just leave it at, do we know what homework number we're on? What was the last homework? That way I can I want to give you a starting point for the next assignment, so I'll call this whatever template. Homework 11 was the last one that was due, or this would be, okay. So homework 11 template. Okay, so let's look at this, and I need to update this guy. Okay, so pick your application name. This company domain thing, you can really put whatever you want in here. It usually follows, a format kind of like a website. So typically you would say something like some name, maybe your name followed by .developer.com or something like that. Doesn't really matter for us, but where this matters would be if you actually were going to put it up on the Google Play Store. You need to have like a bundle identifier, so that's where this guy plays in. At some point, we'll probably do that. It's not overly difficult, but that's the only place where this becomes important. Okay, for your homework and stuff, it's completely unnecessary. And then pick a place where you can find it. All right, we're also going to be looking at a tool called GitHub. How many of you have ever used GitHub before? 0.25? 0.25 people. Okay, good. So we'll be talking about another industry standard application here in a few minutes. We might not get fully to the GitHub stuff today, but we'll get close to it. We'll see. Okay, so right off the bat, when it pops up, the default usually is phone and tablet, unless I think if you click on one of these other ones, then maybe the next time through it's a different default. But phone and tablet is what we're going to do in here. So that's a type of application we're building in Android Studio. And then they're asking, what's the minimum SDK? All right. So within Android, I think, did we talk about the fragmentation issue last time? No, yes? Like there's, yeah, like there's different Android devices, different versions of the operating system. Like how many of you are running Android? I think I asked this last time, and what's operating system you have on there? So the issue is that I think we did the little poll in here, right? And we had 3 or 4 different versions of Android we were likely running. Like you thought you were running Android 6, and you were probably running 7 something, and that kind of stuff. So the idea is that when you're writing software for Android, especially if you're going to release it on the App Store, you want to pick a SDK that will hit an SDK that has all the stuff in it that you're going to use for your application, all the new features, but that can target the most devices, where that balance point is, right? Because each time the next version of Android comes out or the next version of iOS, if you're an iPhone user, comes out, there's some new little widgets they introduce into the operating system, some new effect or something like that, right? And those are things that you might want to incorporate into your applications. Now, if you're writing a little business utility widget application or something like that, maybe those new things don't make sense. You don't need them for your application. So if you don't need some newfangled thing for your application, then you might as well go to an older SDK so that you can target more devices. All right, so if I go back to whatever the operating system was 4 years ago, let's say, for Android. So this is Android 4. So that would be roughly 4 years ago, whatever the release date was, but let's just call it roughly 4 years ago. I'm going to hit a lot of devices that are in circulation today. So most people who have a smartphone, it's a phone that's going to be within 4 years old, right, on the Android side. So chances are it's running an operating system that's at least as new as Android 4.0, 4.3. And as long as the stuff I'm going to put into my app, the widgets, the drop downs, whatever it is, was available then, I might as well target that SDK so that anybody who has that one or anything newer can run my app. Make sense? If I'm going to write an app that's taking advantage of some brand new thing that came out with Android 8.0 Oreo, well, now I'm going to be very limited on who can run my app today. In 6 months, it'll probably go from some percent to 1% or something like that. But you get the point. Only you limit who you can target depending on what version of the operating system they have. This is an aspect of Android that isn't as good probably as iOS. So Apple, when they release their new operating system, all of their devices get it. With Android, whenever they release their new operating system, the only devices that get it immediately are Google Pixel. So Google's actual devices. Before that, it was the Nexus phones got it. But now they have their own brand. But whatever, those are the ones that get it immediately. After that, you're at the mercy of the phone manufacturer as to when they can put that newest operating system on the device. Why is that? Does anybody know why that is in the Android world? For instance, this is a Samsung Note 8, popular phone, right? I still don't have Android 8 on here, and I may not have it for 6 months. Why? What's the delay?
It might have been more designed for the newer hardware.
This has actually newer hardware in it than Pixel 2, or every bit is new. Processor in this is a newer processor.
Some of it is a bit of a business decision. If you have exclusivity, you're going to sell more units.
Yeah, Android is open source. Yeah, Samsung has access to Android 8, no problem.
Well, in Samsung's case, they also have to make Samsung.
Yeah. So that's the kicker. So if you have anybody in here have a Pixel, either a Google Pixel or Pixel 2, okay, has become a pretty popular Android phone the last couple of years. It's only a couple of years old. But what you get with the Pixel that you don't get on other Android devices is it's running Android natively. No changes. It's exactly the Android operating system. How many of you have a Samsung phone? Okay, so on your Samsung phone, it has, let's call it mostly Android, but there's some other Samsung crap installed on here. How many of you have Bixby? Okay, so I have Bixby. Bixby is Samsung's version of Siri, version of Google Assistant, and then is there another one out there? You can get Alexa and Cortana, but they're less integrated into Android. But regardless, Bixby is the Samsung specific Siri. Okay, as if Google Assistant wasn't good enough. And what's funny is when you watch the comparisons of them, each one is like good at certain things. You don't have like this one like this good assistant across the board. But in any case, and also this guy even has a Bixby specific button, which you always accidentally hit and you get ticked off that Bixby is talking to you and you don't want to use Bixby. You have the specific button. It's terrible, right? Yeah, man. But in any case, punchline is that if you're not running a Pixel, the Android device that you're on has Android as the core operating system and then has thrown software on top of it to enhance your experience or something like that relative to what that vendor has decided makes the best experience. Okay? Like it or not, that's the reality. Okay? So when Android 8 came out, and it dropped actually before this guy hit the shelves, but well after this guy was designed and stuff like that, right? So is that your ringtone? Or he's watching a video? He's watching a video. Back row. This is terrible. All right. So in any case, I find that hilarious. All right. So in any case, when you're holding this thing, this guy had all of its Bixby stuff put on specifically targeted at Android 7.3 or whatever the latest revision of Android 7 was. So in order to make it work for 8, they would have to look at all the new stuff in Android 8 and then port all the Bixby stuff over to it, make sure all the bugs are out, all that stuff. That's going to take time, right? And I don't even know off the top of my head what's really new in 8 versus 7. I'm sure there's some good stuff. I'm sure there's good stuff. Okay, but that's kind of the world of Android that we live in today. And it's okay because if you're running a recent version of the Android OS, you feel okay. Right? You know, you're not like, oh my gosh, I'm so behind the times. It's not like a jump from like Windows 95 to, you know, Windows 10. It's not that big of a leap. All right. Now, having said that, iPhone really wins this war. And that's not so much that Apple is better. It's because all of Apple's devices are made by Apple. So when they release iOS 11, it's as if they're releasing Android for the Pixel. Make sense? It was designed for those devices. And then you have some unethical things in there that Apple would probably never admit to, but seems to be true, where technically iOS, they'll say, well, like for instance, the newest iOS is iOS 11. Right? It's the current version of iOS for the iPhones and iPads. Well, iOS 11 definitely works on the new stuff, right? The new devices. It works on iPhone 7s. Works on the 6S, and I think it works on 6. Anything newer than that, or older than that, you can't upgrade to iOS 11. But if you put iOS 11 on an iPhone 6, it's sluggish. So it pops up and says, oh, get the latest greatest software, blah, blah, blah. You download it, right? Now all of a sudden your phone is slower than it used to be. Battery life is worse because it's trying to do some stuff that the hardware wasn't really built for. It's stretching it. So what do you have to do now? You go buy a new phone. Give Apple more money. I mean, well, Apple needs more money. They really do. Apple's not the only one playing that game. All the big companies are. So don't demonize them. Demonize all of them is what the punchline ends up being. But in any case, Apple's not doing anything different than maybe Google is doing with Android and the Pixel. Just Apple has that entire market, the iOS devices, is all under one umbrella, Apple. Where the Android market is, you have the Android umbrella and you have 50 different phones underneath that. That's probably an underestimate. Okay? So in any case, pick a target that fits your needs. For us in here, we're going to be making simple apps. You could probably pick API 2 and it'll be okay. Notice here with API 15, it says you'll hit 100% of the devices. If I jump to, let's see, you said you were running 6.0, you thought? So Marshmallow will hit 49% or 39% of the devices that are out there in circulation. Okay, well, that doesn't seem so good, right? It's probably lower than we expected. Well, it's because a lot of these devices don't update. Sometimes they never get the update to the next version of Android. They're stuck with whatever they had initially. That's less true today because there's some strategic partnerships between Google and some of these other, some of the, let's call it the top tier premium companies. So HTC, Samsung, we'll throw Nokia in there, but the big brand companies. There's some strategic partnerships there where there's a goal of getting Android, the newest version of Android, onto those phones sooner rather than later. Whether that actually happens or not is a whole different thing. All right, and obviously as we keep going, Android 7, we're at 8%. So if you're running the same version of Android, well, actually that's 7.0 is that one. 7.1.1, which is what I'm running on here. I'm sure it's going to go down. That's 1.5% of devices is running the operating system I have on this. So if you're targeting this, you're targeting probably premium devices, but a very small percentage of the Android devices that are living out there. And then, if we go to Android 8, it says 1%, but I'm sure it's far fewer than that. All right, so we'll go back to, what was it, 17? It's 96%, 16, 99.2%, 15 ice cream sandwich. So Android 4.0.3 hits all the devices. That was the default on here. We're going to say that's good enough for us. Okay? But do we understand that world there where we pick the SDK? Until you know different, might as well pick the one that's 100%. So we'll go ahead and hit next. Now, I like to always start with an empty activity. So what this screen is showing here is it's like, what starting point would you like me to give you? Now, once you become a more advanced application developer, if you know that you're writing an app that has kind of a navigation bar here on the bottom where you can click on the different buttons to flip between different screens, if you know you're in that world, you might start with that. But certainly for us now, because we're learning how the interfaces get put together, but actually, I always like starting with an empty activity because then I have full control. Because if you start with like a basic activity, which is what a lot of tutorials kind of try to convince you to go into, Google has done a lot. Well, yeah, I guess it would be Google has done a lot of the work for you for that initial setup, and then you have to kind of learn their way of how they've organized that app. It's not horrible, and there's not that much stuff there initially, but there's extra stuff that you have to learn that we shouldn't have to worry about initially. All right, so I like to start off with a completely empty activity where they've done none of the extra work for us, so we have a blank canvas to work on. Okay? So choose empty activity. And then it's going to ask you, what do you want to call your main activity? I'm going to talk about activities here in a few minutes because we're just throwing that word out there right now. But, historically, we say all programs begin and end with main. So main activity kind of coincides with that. So we're going to go ahead and call that main activity. Now, we've talked about, I know we talked about it last semester, at least in passing. We talked about design patterns, right? Anybody remember what a design pattern is? I think we've actually even mentioned it again this semester. So I usually introduce this guy as a proposed, quote, good solution to a, quote, common problem. So that means a design pattern can literally be anything, okay? And I usually, when I introduce this, I kind of talk about it was created by academics. We've heard this idea of publish or perish. Concordia is a little different because we're a teaching school, but some of the faculty here, like I'm a research faculty here, so we have a publication requirement. We need to have topics that we can publish on. Design patterns are great because all you have to do is propose. Let's replace good with reasonable solution to what's a common problem. If you work for Lockheed Martin, a common problem might be like, missile tracking or something like that. Okay. So a common problem could be almost anything, right? And what's a good solution? Well, let's call it a working solution that you think doesn't completely suck. So you can write a paper on that. And design patterns also have to have funky names. It's an unwritten rule of design patterns. All right, so you can write one, release it in the public. That's research. You're advancing the field of study. Then somebody else comes along and says, that's a crappy idea. Here's a better solution. No problem. I still got the publication. Okay, that's research. All right. But anyways, so a design pattern is the concept of designing solutions for common problems. All right. Now, while we can literally have an infinite number of design patterns out there, and you see there are a dime a dozen in the research community, over time, some ones bubble to the top as widely accepted. And one of them, and the one we're going to talk about right now, and I probably introduced this last semester, at least at the high level. Did we talk about MVC? Ever talking about that? So just a maybe, so possibly, and regardless, we don't remember. Is that a fair statement? Okay, so MVC stands for Model View Controller. All right. Now, self-explanatory, so we can just leave the slide there. We have no idea what that means, right? Somebody came up with a design pattern. They called it Model View Controller and then shortened it to MVC because it sounds smart. But what does this guy really say? It says it's a good idea to keep your logic, well, let's call it to separate your logic from your user interface. And I'm going to throw this other part in here, from your data. That's when you throw the database part of it in here. All right, so what this effectively says is write your code in one place, design your interface in another place, store your database in another place, then create a, what's this?
Don't cross the streams.
Don't cross the streams. Anybody know what what movie that's referencing? The original one, yeah.
The good one.
I like the second one.
I don't dislike it. Honestly, I don't really see what people's huge hang-up is.
So, finally, we need to create a mechanism for connecting these separate pieces. All right? So as an application gets bigger and bigger and bigger, it would make sense for us to keep all of our logic in, these files. And then all the things that make the application look pretty over in these files. Forget about the database component for now, because we haven't dealt with that stuff. We'll deal with it more next semester. But in any case, for us, logic, what it looks like. Now, these things are related to each other, right? When something happens over here, we want to update this guy over here. So we do need to have a mechanism for these two things to talk to each other. All right? And that's the idea of MVC. So it's important to consider that MVC, or any design pattern for that matter, is not an implementation. So design patterns are not implementations. They are a suggestion of a way to accomplish something. So for example, we've talked in here about merge sort. We've talked in here about insertion sort. Some different algorithms for things. We've described how you might sort data in different ways. But then you still have to go and implement that to follow that logic, right? And if you have 5 different people implement it, they might use different variable names. They might do it slightly differently, that kind of stuff. Well, with a design pattern, like MVC, it's even less specific. So when we talk about insertion sort, we're actually talking about, very specific, unambiguous steps you have to take to get things sorted. Well, with design patterns, we're just talking about kind of a broad idea. Like, look, you got to keep some stuff here, some stuff here, some stuff someplace else, and then you got to have some way for those things to talk to each other. So you could have lots of different approaches to that problem. Okay? Android has an approach to that problem. iOS, Xcode is the tool they use. So Android Studio is to Android development as Xcode is to iOS development. So they have a different solution, similar but different solution to that problem. Unity has a solution to that problem. All right, so all the Visual Studio has a solution to that problem. So they all have their own spin on how to implement MVC. Make sense? All right, so having said that, right off the bat here, we're seeing evidence of MVC, where they're saying, okay, well, we're going to create your main activity is going to be, in a file called MainActivity.java. Okay, so this is where our logic lives. Layout name, activity_main, this is where your interface lives. Make sense? Separating the two. What it looks like, what it does. So we'll just go ahead and accept that. The defaults are fine there. If you want to name your main activity something different and you want to name your layout name something different, that's fine. In case they're not checked, make sure you do check generate layout file because you might have your own layout files. You might have previously designed some stuff and you want to bring it in, so you don't want it to generate a fresh one. Similarly, there's this other thing that says backwards compatibility, app compat. So over the years, the idea of an activity has changed, and we'll talk about activities in a few minutes. So this app compat thing says, since we're designing to be supportive for some older versions of Android, Android 4, it was checked by default. So this says, even if you're running Android 7, this app was designed for Android 4, so give them a compatibility version of an activity so it runs right. All right, So make sure both of those are checked. We're going to be creating stuff from scratch for now. So go ahead and hit finish, and it's going to do its thing. Gradle is a tool you'll see on there pretty often. You'll never, well, not never, but will rarely, if ever, work directly with it. But Gradle is what's called a build tool. Years ago, it was called Ant. And what Gradle is it takes all the components of your Android application and does all the heavy lifting of compiling them and linking them together and doing all the magic that ultimately allows it to get put onto a device, right? So that we don't have to worry about it. Okay, so Gradle will be something called a build tool. All right, we're putting together some pieces, but the parts of it that we are directly working with are our logic and the interfaces we're designing. But we can certainly appreciate there's probably a whole bunch of other stuff that goes into an Android application that all Android applications must have. And we don't want to have to reinvent the wheel each time. So this Gradle thing is like pre-configured to go ahead and build your project for you. That makes some sense? And inside this folder up here called manifests, there are situations, well, it's actually somewhat common as it's called a polished Android developer, that you'll have to go in and modify the manifest. For us, we're not going to see that probably even in this class. But the manifest is where you put different security rules for like allowing location services and stuff like that. But it used to be that you had to manipulate the Android manifest heavily. You used to have to, every single time you add a new activity, you have to add it to the manifest. Now all that stuff is happening automatically for you. So it's managing all that, frivolous stuff that super important, super required, but really always happens the same way, so it's doing it for us. Make sense? So we will likely never touch that manifest file. So our world really lives here. Inside of the Java folder, in this top thing, so notice we have three different things here. We have Android test, we have a template test, and then we have our actual template. These other two things down here are for things called unit testing. I'll talk about the high level here real quick, but we won't use them. But has anybody ever heard of unit testing before? All right, so unit testing would be automated testing of your software. Now, it's not that it comes up with the test on its own. You still have to write the unit tests. But as you're working on your homework assignments or whatever, you write the function and you test it with some of the inputs you think should work for it, right? And you see the output. Well, you could imagine as an application gets larger and larger and larger and isn't something that you're working on over a weekend that you turn in on Tuesday and then you don't forget it, then you don't think about it again. If it's a living project that people are constantly working on, people are constantly making add-ons to it, it might make a lot of sense for you to create actual test scenarios where this project needs to work for this unit test. It needs to work for this unit test and this unit test and this unit test, where you give it, here's the input, here's the expected output, give me a thumbs up if it worked, a thumbs down if it didn't. Okay? Because the idea is your application should pass all those unit tests. And over time, you're going to add more and more unit tests. So let's say maybe initially you create 10 unit tests. Here's the 10 things that I thought of that my program should work for. Okay, and it passes all those. Great. I release the software now. So now a bunch of people are using it. Somebody comes back and says, oh, when I do this, this, and this, it breaks. So then I go in there, so it's a bug, right? So now I fix that bug. I add a unit test to test against that thing that I didn't previously think I needed to test for, or I didn't previously conceive of that test. So now I have an 11th unit test. All right, so now I know it works for that one because that's the thing I just fixed. But I might have broken other things in the fixing process, right? So now I can just hit a button and test it against all my other 10 unit tests. As long as I get a total of 11 thumbs up, program works at least as good as it used to, from my perspective. So you can imagine that over time, you're going to get this giant collection of unit tests for all the bug fixes and things like that you've added to the software. And every single time you make a change before you release it, you want to make sure you get a thumbs up across your unit test wall so that you have the most confidence you can have with releasing it. Now, that would be preferred over you kind of trying to haphazardly remember, oh, well, I need to make sure it still works for this, and it still works for this, and it still works for this, and you end up testing 5 things instead of the 30 things that you actually should be testing just because that's what came to mind as you were testing it, right? So That's more of a industry reality type of issue rather than something we deal with in here, just because we're doing homework assignments. So this is, but do we kind of get the purpose of that unit testing world? All right, so we won't mess with them in this class. Later on, you will see some unit testing stuff, but in here, it's off our radar. So you could ignore these bottom two things. Anything that says test after it, Android test or just test, you could ignore. We care about just our normal plain Jane folder. Inside of here is our main activity. This is equivalent to our driver.java. All right, so this is our the Java file that has our main activity stuff in it. So let's go on a tour through this guy. So here's our main activity, and I'm going to go ahead and fix these curly braces because I hate them. Now, I'm also going to go ahead and expand this folder called res, resources, and then inside here we have a folder called layout, and then here is our activity main, and they had actually already opened it here. So that's what this guy looks like. I'm going to go ahead and just move some stuff this way to make that a little bigger. Yeah, whatever. We'll just say that's good. We can actually zoom in here too. All right, so this is how we're designing our interface. And notice they've given us kind of a starting point, and see it already says hello world on there as your starting point. But let's see how MVC is actually accomplished in Android. So we're seeing it at the high level. Here is our logic. Here is our design. Two separate files, two separate purposes, right? But now we've mentioned that there needs to be a way of connecting these guys together. So if I go to my logic here, we have this function here called onCreate. And let's go in here real quick and let's talk about Android apps. An Android app is a collection of activities. Okay? Collection of activities. And if I want to just do some connection here, if I say iOS apps, these guys are collections of view controllers. Let's call them rough synonyms. Activities and view controllers are basically the same thing. So even though you're learning Android development in here, you're effectively learning iOS development. They're similar enough that once you know one, jumping into the other one is just about learning their, where their tool has the different things and that kind of stuff. The organization is mostly the same. All right, so for us, Android apps are a collection of activities. Well, now, what's an activity? An activity. At the high level, we can think of an activity as a screen in our app. So every screen in your application is an activity. Right? And you've actually seen this if you're an Android user. But if you're a newer Android user, you see it a little bit differently than an older Android user. That's what that whole activity compat thing came in for compatibility activities. So I think it already worked this way in 6. So I don't think any of you in here have seen this. But in an older version of Android, when you opened up applications, what it effectively did is it opened up the main activity for that application and it threw it on a stack. Okay, so what you saw on the screen was whatever activity was on the front of the stack. Okay? Now, all Android devices have a built-in back button, right? You have a button on there that goes back. And what does that guy do? It goes back to whatever the previous activity was. So it takes the dude off the top of the stack, puts him someplace else, probably the bottom of the stack, and then you see whatever was underneath it, right? So let's say you went into some banking application. So you go into the banking application, the first screen is login. So you log in and it takes you to another activity. So what just happened is you have the login screen and then you have this other activity just got slapped on top of it. Okay? In older Android, if you would hit back then, it would take you back to the login screen. Make sense? A lot of times it would automatically log you out then. And some applications might still work that way today. But let's just assume that's the way it works. So you're now in the Bank of America app, let's say. You logged in, now a new activity got put on top. If you hit back, you'll go back to the previous activity. Now, what if you hit the home button? That's going to close that, well, it doesn't close it, but minimizes the current running application, which is a collection of activities. And now you're doing other stuff, right? So let's say you launch Microsoft Word or something like that on there. Now, in older Android, if you would hit back a couple times, you'll get back to the Bank of America app. Okay? Newer Android, it won't work that way. Does yours work that way in Android 6? Okay, it does. So I think it's even older than 4 when it worked this way. So now what you have is you have stacks within an application. Because this became problematic before. Even with the whole back button trick, you could say this. If I minimize the Bank of America thing, and then I open up Microsoft Word, then I go and I go back into Bank of America. Okay, so now Bank of America is back in the top. When you hit back, you expect to go to the previous screen within the Bank of America app, right? That's how it works now. But in older versions of Android, it would go to whatever the previous screen you were looking at was, which was Microsoft Word. Make sense? So it used to be that the Android operating system was just a stack of activities, and it didn't matter if you were crossing activities, it was crossing applications. You were just looking at whatever the previous screen you were looking at is. Now it's smart enough to say, oh, your context just changed to, I'm running the Bank of America app. So when you do that and you hit back, I want to go to the previous screen within this app. Make sense? So more of just a user experience type thing. But for us, we can think of activities as just a single screen inside of our application. That's more true today than it was historically, because we would have said historically it was a single screen inside of Android and it happened to belong to some application. So this is a single screen in our app, and this guy has a life cycle. And what I mean by that is it has various points in time where we can perform logic as the activity is launching or showing on the screen or about to go away, etc. So you have points in time where we can, we can do different things. If you're about to minimize an activity, you might want to, pause an upload or something like that. There might be some bookkeeping, record keeping type stuff you want to take care of before the application actually goes into the background. If it's first when an application first actually appears on the screen, maybe you want to start some animation. Okay. Now the one we care about initially, that's given to us by default, is a lifecycle component called onCreate. So this guy is when this activity was first created. It's called one time when the activity is first born. We can kind of think about this like our constructor for this activity. This is where we would put our initialization stuff. Okay? So stuff that we want to happen right when the activity first comes into existence, and we only want it to happen one time, we would put inside of onCreate. And we'll see examples of that. Okay? And that's the only one I'm going to introduce right now. Let's keep it as simple as possible. So for us, activities, we believe they have a life cycle. We believe they can respond to lots of different things, but right now they only know how to respond to their birth. Okay? So we have one opportunity to do something. So we go back to our code here. We see that we have this function onCreate. And it gets this thing called bundle saved instance state. Don't worry about that. That has more to do with the current context of your device and the current application running and what its current state was for things when it when it was minimized and comes back. That guy has some information in it that we might want to use in a more advanced application. For us, it's part of the syntax. That's what this function takes. OnCreate takes a variable of type bundle, whatever that is. Okay, now remind me, what is super? Yeah, so we've talked about two keywords, right? We talked about the this keyword, or we talked about the super keyword. Keep in mind, this is still Java. We're using Java to implement Android applications, but this is still Java programming. So the super keyword is how we talk to our parent. This is our class MainActivity, and this guy extends this dude called AppCompatActivity, whatever that is. Kind of like all of the objects we've written extend object, right? Even though we didn't write that. This guy's specifically extending this thing called AppCompatActivity. Whatever he is, we're not going to worry about it right now, but it's somebody else. It's my parent. All right? It's whatever the most generic version of an activity is. Kind of like in the objects we've worked with, the object class is whatever the most generic version of an object is. Okay? So what are we doing here? We're just going to go ahead and let our parent call their onCreate method, passing it the exact same thing we got. Like, look, parent, go ahead and do any setup you need to do, and then I'll take it from there. That's all that line says. All right, and it's always provided for you in the syntax, but that's what it does. All right, now I'm going to go ahead and update this because you've seen that I like using this dot. So I'm going to say this dot set content view. So set content view is a function. Is it a class function or an instance function? Class method or an instance method? How do you know? Yep. So this is an instance of this class. This is how an object refers to itself from within itself. So set content view is a method that belongs to an instance of this class. This class is a MainActivity, which is an AppCompatActivity. So this must have been something we got from our parent AppCompatActivity. All right, and this is how we call it. Again, it was called for us, but right here is where we're seeing the first part of the MVC implementation. So this particular activity is setting his content view, that is what his interface looks like, to activity main. This is when we glue our logic to our design. Make sense? That's where MVC is getting connected together there. We're letting this activity know about what he looks like by setting this activity's content view equal to activity main. Now, some interesting things here though is we have this guy called R right here. Let's talk about R. It's called the R class. Okay. This is a class automatically generated and regenerated by Android that houses all of the resources that we create for our layouts, let's just say etc. Because it's not just layouts, it's also like images and that kind of stuff. All right, so the way Android pulls this off, so again, this is communication between, so this is how they've implemented MVC. So Android said, look, we're going to create this class called R. And whenever you create a XML file for your layout or something else, so in this case, we have this main, activity main. This is a layout. When you created that guy, we automatically created an entry in this class called R for him. Okay? That way, so this gets managed for us. Every single time we create a new layout, it automatically gets added to that class. We don't have to worry about it. So R is always the latest collection of our resources. So in here, we're saying, look, I need to get to activity main. Well, activity main, we've named him activity main.xml, but computers like numbers, like some weird identifier. So where does this guy live? Well, he lives inside the layout folder. We saw that over here. But we're going to get that information from our R class. So we're going to say, R, give me one of your layouts. Which layout? The one called activity main. Make sense? So we're getting activity main from the R class, and that is automatically kept up for us. And you'll see that here in a few minutes when we make an adjustment to this. Okay, so this gives us our full MVC connection at the highest level. Now, I'm going to go ahead and I'm going to hit play here. And it's going to launch this deployment target thing. And it's going to, so first of all, if you plug one of your devices in, if you have an Android device and you plug it in through USB, you can run this app directly on your device. No problem. Otherwise, we have some virtual devices here. I've previously created some. If you don't have one by default, if you go to create new virtual device, here's the options for those. I would go ahead and pick like the Pixel. That's going to be a pretty modern device. So pick the Pixel, hit next, whatever, and that will ultimately give you a device that looks like this. And it's running API 23, which is backwards compatible with whatever we picked, API 17. All right, so this is last year's Pixel. So it's a new enough device that it can run the stuff that we're writing here. So I'm going to go ahead and launch it on the Pixel. So I'll select that virtual device. This is effectively the Android simulator. So I'll hit OK. And it's going to try to launch this Android, well, it calls it the Android emulator. iPhone calls it the iPhone simulator. Here is an emulator would actually be running the Android operating system, where a simulator would be simulating the iOS operating system. Just a means to an end. All right, so that's my Pixel. It's always interesting when you look at it like this, how much like an iPhone the Pixel looks. But that's okay. That's why it's nice to have competition, right? Somebody comes up with something good, somebody makes it better. Now, with these full screen things from Samsung, now Apple's trying to copy that with the iPhone 10. We'll see how that goes, but keep one-upping each other and we benefit. So there's our first running Android application. Okay, so now let's talk about GitHub. Okay. So now, first of all, the reason we have to look at GitHub here is clearly there's more going on over here in this project than there has been in our Eclipse projects, right? More stuff, even though we're only touching a couple of pieces of it. Okay? Not that much of it are under our control, but they're still part of this application. So what we want to do is we want to be able to store this somewhere so that it's easy for you to share a link with me, for me to look at your work. All right, so there is a technology called Git. All right, so if you're on Mac, Git is already installed. If you're on PC, you have to download Git. So you would go to Git Windows. But we're not going to use the GitHub GUI because we're going to use the thing directly from Android Studio. Yeah, so you would go to Git SCM here. So just do a search for Git Windows download. Go to Git SCM, and then download it for. Actually, you already started downloading it as an exe, but whatever. So it'll figure out whether you have a 64-bit or a 32-bit operating system, and it'll download the appropriate Git. For us, it won't matter. If you pick 32 or 64, it's fine. All right, so download Git, double-click on it, run, just get it installed, and that's it. You're fine. Now you have the client, okay? Because there's really two different pieces here. So Git is what's called a source control application. Okay, it's really made for so it's made for collaboration on larger projects between multiple users. So the Git protocol actually supports a whole bunch of stuff that we're not going to use. All right, so what it effectively does is it creates a repository. So the code lives here in this Git repository. Now let's say we have a couple of programmers who are all working on the same project. What they would do is they would check out the repository, make some changes, commit those changes, and now that repository has been updated. Make sense? Now, this guy could then check it out, make changes, commit those changes, now it's been updated. Well, what if they both check the project out? So now they both have equivalent versions of the project. They're making independent changes. They commit their changes, and now this repository has been updated, and possibly some of those changes are in conflict with each other. If they were working on different files, maybe not the end of the world, but there's a possibility there's a conflict. So what Git has is it has the ability to merge changes, but it also shows you what the current conflicts are so you can resolve them. It might mean that you have to reprogram some stuff, but it at least shows you this dude made these changes, this dude made these changes, these guys, is this a problem, or can you just merge these together and say we're good? Okay? These are all things that Git will do. Well, we're not going to be using Git for those features. Those are the advanced features of Git to manage large projects. What we're mostly going to be using Git for is because Git is the technology that GitHub uses, and we're going to be using it to upload our project to a remote repository, which will then give you a link that you can just submit in for your homework. Okay? So let me show you GitHub, and then we'll see this in action. So github.com, and this is, again, it's an industry standard thing. You will use GitHub if you go and get an internship somewhere or you're working in industry for computer science. GitHub is an industry standard. And they've built that through this model that we're going to talk about here. So GitHub is completely free. A whole bunch of open source projects are available on GitHub. When I say open source, what do I mean by that? Okay, yeah, so it's 99% true. So open source means the source is available, right? So anybody can get it. So you can download that, you can manipulate it and make changes to the source code, some of that, but you can't push those changes back to them. You can't destroy their thing. You can make it your own and create a new version of it. So for example, and so we'll cover some of the unfortunate nomenclature here first. So when you go into a particular project on GitHub, so let's say we were, we'll go to GitHub here, and let's go to Discover Repositories. Let's say you're just looking for a open source project to get involved in, okay? So we're just gonna pick this first one, Airport Manager, all right? So this is some airport manager developed by somebody. We can go down to this README. Probably, I don't think it's Russian. Is it Polish? Yeah, whatever. Awesome project. I encourage you all to get involved. Okay. In any case, if we were interested, I mean, first of all, you can probably apply to this project and they might give you commit privileges if they decide that what you've worked on is good and they want to have you actually part of the active development of it. You can do that. But let's say it's like the base of something you're interested in working with. What you can do is, like we just said, you can create a copy of it and then work with your copy to make updates and stuff like that. Now, the way we make a copy is we fork it. Okay? When you say that word, make sure you fully enunciate. Okay? Fork the project. So, and this isn't something that is a GitHub thing. This is actually left over from, this is an older computer science thing that actually still exists. You'll probably talk about it in an operating system class where you, today we have multi-threaded applications. You've heard of that idea before, where an application spawns off multiple little threads, little worker bees to do different logic for it, things that can happen simultaneously. Well, before we had multiple threads, we had multiple processes, okay? And the way the system call in an operating system to generate a clone of the current process, if you had one process that was working on something and we wanted a second one to help it to, two is better than one type thing, what we would do is we would fork the process. So you would use the fork system call, and that fork system call, it's a function, would return a value. It would return a 0 if you were the child, if you were the new guy. And it would return some process ID, the unique identifier of the child, if you were the parent. So if I'm the parent, I would fork a child. Seeing how this kind of becomes questionable actually, a funny story I'll tell you in a second. But okay, so you fork a child process, and then you can ask the question, am I the parent of the child? Because what you just did is you made a duplicate of these two programs. So then you ask the question, if PID is equal to 0, I'm the child, therefore I'm going to do the logic that the child was supposed to do. Else, I must be the parent, I'm going to do parent stuff. So that's how we can divide who's doing what parts of the work. Okay? Now, that was an effective way of doing things, and actually a very powerful way of doing things, because if you had two physical processes, they actually got twice as much time on the CPU. Because operating systems schedule the CPU based on some amount of time. So each process gets an amount of time on the actual CPU. So if a certain program duplicates itself and becomes two separate processes, each of those processes gets their own amount of CPU time. So nothing would keep a program that could divide its work up to go ahead and spawn off a whole bunch of child processes and be able to take a whole bunch of your CPU time. It was also a very popular attack on operating systems because every single time you launch an application, so from our perspective, when you double click on a program and that program launches, what do we get? We get a new process ID, a new program, a new process is born. Well, depending on if you have a 32 or 64-bit operating system, whatever it is, the total number of processes that you can have on your system will be different. So let's just assume for us, in a little bit older operating system, that we could have a maximum of 65,536 processes. All right, we've heard that number before. It's an unsigned 16-bit integer. So that would be like a 16-bit operating system. So you have a 65,536 unique processes. Well, what if you called fork 65,536 times? You've just given birth to 65,536 processes. Now you're out of process IDs. And let's say each of those guys just went into an infinite loop. How do you fix it? Well, you could say, well, we can go and kill off programs. What do you do on Windows? You Control-Alt-Delete, go to Task Manager, and you start killing off the stuff that's dying, right? What's the problem? Isn't Task Manager a program? You're out of process IDs. You can't launch it. So you can actually make a computer completely unusable because you can make it run out of the ability to launch more programs. So then the only way to fix it is to reboot the whole machine. Well, if you're at home, that might not be the biggest deal in the world. If you have a mission critical server that is in the middle of a backup or something like that, that could be problematic. So really simple things can lead to big problems. But the conversation I had was I was a Unix system administrator years ago, and we were at some restaurant having breakfast and having a discussion about this program we were working on, and we're sitting there talking about forking children, and we had this other thing called the Reaper, where we were reaping child processes, killing them off. So we're killing children, we're forking children, we're killing children. And there's this old lady sitting at the table behind us. Was getting upset. It ended up being funny in the end once we explained it, but yeah. So you can there's just some unfortunate historical verbiage that has been born into this. But in any case, here that's where that fork word comes from. So what I might do is I might click on fork here, and what that would do is it would make a duplicate of this repository in my collection of repositories under my GitHub account. And what that then lets me do is I can check it out from my GitHub account, and I have permission in my GitHub account to make changes and commit those changes back up. So that's actually what you'll do in here. When I give you something to work on, I'll push to my repository, to my GitHub, a template, a starting point for you. Then what you would do is you'll go in, you'll create your GitHub account. It's free, doesn't cost you anything. You'll click fork, and what that will do is it'll make a duplicate of that repository in your GitHub account that you have permissions to write to. You'll then check it out from there, work on your homework, commit the changes. Make sense? And then you'll submit the link. That's the kind of the work process for it. Alternatively, you can also just download a zip of the folder, but ultimately I'm going to want you to submit it back to GitHub. So the easiest way of doing that is to fork it, check it out, then push it back up. All right. Once you do it a couple times, it's not hard, and the tool is built into Android Studio. You know, just got to do it 2 or 3 times. You'll kind of get the process for it. All right. So once you have a GitHub account, so I want all of you to get a GitHub account. It's free. What their model is whenever you push something to GitHub, it is publicly available. So GitHub is kind of our main world hub, if you will, for open source projects. There's some competitors with it. There's another one called Bitbucket, and there's probably a dozen other ones that are similar. GitHub is the popular one. That's whatever. It's the big fish. So, having said that, they're getting a whole bunch of developers used to using GitHub. They're comfortable with GitHub. They're comfortable with the way it works. Blah blah blah. Well, now when you go and work for a company, and you're working on, so let's say you're working on the latest, greatest video game or software application. Chances are that's not going to be an open source project, right? You probably don't want the whole world to see the next version, the source code for the next version of Windows, for example. That's where GitHub's business model comes in. So now, because you're used to using GitHub, and the developers say, "Oh yeah, we like GitHub, it works, we're used to the workflow." Now, what the people will do is they'll buy a private repository. So that's where you're paying for. It's like $10 a month. It's not prohibitively expensive. But you'll buy a private repository, which means that it's off everybody else's radar. Unless you give somebody specific access to it as a collaborator, they can't see it. But now GitHub is making money. Make sense? So get us all on board using it because we like the tool and we're used to using it for free. And then all of a sudden, when the downside of it being public becomes a problem, then we don't use it for free anymore. Okay, so just to kind of show you the process here. So I'll go back into Android Studio. Now, so whether you're on Windows or you're on a Mac, if you're on a Mac, Git is already installed. If you're on Windows, you should have installed GitHub by this time. Okay, so what you'll do, you should have installed Git on Windows at this time. So you effectively have git.exe on your computer. You won't have to use it directly, but Android Studio is going to rely on you having Git installed on your computer. Whether it came pre-installed or you have to download it from Windows, it's going to rely on it being there. Once that's there, let's say I've worked on my project from scratch. I'm ready to share it. I didn't check this out from another repository. This is my baby. Okay, so this is what you would do if it's a brand new Android project that you've been working on and you want to get it onto your GitHub account for the first time. I'll go ahead and go to VCS. This is version control. And we're going to say import into version control. And we're going to share project on GitHub. So this is access to GitHub. The first time it's going to ask you for your GitHub username and password. Okay, so make sure you've signed up for an account at GitHub first. So you need Git installed, you need an account at GitHub. Because remember, Git and GitHub are two separate things. Git is the protocol for keeping track of all your changes and stuff like that. So you get a local Git repository on your computer. GitHub is a remote location for remotely storing your repositories. So after you push something to GitHub, your repository actually lives in both places. You have a local copy of your Git repository, and then you have a copy up in GitHub. Now, the one we care about is the one in GitHub, because after we push to GitHub, we can actually delete the code from our computer if we wanted to. Okay? So, I'm going to show you a couple different ways we use this. So, I'm going to create a new repository name. We're calling this CSC250 Homework 11 Template. Now, the remote name, leave it as origin. That's kind of a naming convention that all Git repositories use. So the default branch for this is going to be called origin. When we talk about branches, when you have an application that gets launched, you might have 3 or 4 different branches. You might have release. You might have a beta branch for the next version that's currently being worked on. You might have a couple of alpha branches for like future features that aren't even close to being ready to be released. But within one repository, you can keep track of a whole bunch of different versions of that project. Okay, but for us, we're not going to have to worry about that. We're always going to put ours in origin. So I'll just go ahead and hit share. It's going to pop up here. It's already checked everything. It's saying, hey, here's all the stuff that you're sharing. This is the default stuff that we'll have to share here. Then you get a message with it. Usually you'll just put an initial commit for your initial, I'm initially putting this thing up there. So I'm going to go ahead and hit OK on that. So just accept it. Now, like I said, if it's your first time doing it, you would have had to put in your GitHub username and password. And then you can hit a checkbox that says remember me or something like that. That's why it didn't ask me for it. Okay, so at this point, if I go back to GitHub, let's go ahead and hit refresh here. We see we have this template there. So there's my project on GitHub. Make sense? Now let me show you the other half of it. So the other half of this here would be that, so I'm going to pretend to be one of you now. So I'm going to go ahead and just close this project. All right, so you open up Android Studio, you're sitting at a screen like this. The first thing you would have done is you would have gone into GitHub. You would have, I'm going to give you a link to this project. You would go to this project and you would click fork. And what fork will do is it will make a copy of that project in your account. Okay? Once you have that, then go to your account. So it should have your username here, followed by CSC250 homework 11 template. So make sure you're on that screen. So now I'm pretending like I can't fork my own repository. So in any case, so now I'm sitting here and I'm going to go ahead and copy this URL up here. That's the location of this Git repository. So I'll go ahead and copy that. So this is after you've created the duplicate on your account. You want to check it out from your account. All right, so you want to make sure the screen you're on has your username followed by a slash followed by the name of the thing you're checking out. So just get the URL from up here. Now we're going to go into Android Studio. So I just opened Android Studio on your computer. You've already gone and you forked it. You haven't downloaded this to your computer or anything. So what we're going to do is we're going to check out a project from version control. I'm going to check it out from GitHub. So it's making sure it has the username and password to GitHub. Did it die? Try that again. There we go. It must have had a hiccup when it tried to connect. So here it wants a couple different things. It wants to know what directory name I want to put in here, where I want to store it. I'm going to go ahead and check it out to my desktop here because you remember I stored it in my Dropbox. So I'm going to pretend like I'm actually checking it out to a different location. Okay. So what I'm going to do is I'm going to paste in that URL I copied. If you want to make sure it works, go ahead and hit test. It'll test it and it says it was successful. So it knows that that's a legitimate GitHub repository. I'm going to check it out to the desktop. That's what it was defaulted to, but check it out to someplace you can find it. Because what this is going to do is going to download that repository to your computer. And then I'll name the directory the same thing. It automatically put the name in there. So I'll go ahead and hit clone. So this is making a clone of that repository. So you have checked out the studio project. Do you want to open it? Go ahead and hit yes. Now, sometimes you'll get like a weird little error message here, and I'll tell you why here in a second. Okay, so it says it cannot load 2 modules. Go ahead and hit detail. Just say keep all. This is really a Gradle problem. If you notice down here, when it popped up that error, Gradle was still running. So it was like a cart before the horse type issue where it tried to load something before Gradle had finished building it. So just hit details and hit keep all, and life will be fine. Okay. Then it also asks you something like this. Do you want to add the following file to Git, this vcs.xml? This was something that was just generated by Gradle. All right. So Gradle's kind of our enemy here because it does take some time to process this. They probably need to fix the way the checkout works. But in any case, just hit yes. And if you want, you can even say, remember, don't ask again. Android Studio is going to keep track of all the files you create. Whenever you create a new class, a new activity, whatever, it will automatically add it to your Git repository. The answer is always yes. Okay? Once the answer might be no, you'll know how GitHub works. We won't ever have to worry about that. So whenever they ask you, do you want to add something, just say yes. All right. Gradle build finished. Now you see we have our project here. Here's our main activity. Because we're short on time here, I'm just going to go ahead. I'm going to add a little comment. I'll just put an LOL in there on my onCreate. I'll go up to VCS because I've checked this out. So now I'm saying, oh, okay, I am done. So I want to commit my changes. All right, so it's noticing that I made a change to my main activity. So I'm just going to say in my message here, added comment. And then under commit, you can do commit and push. Because I checked it out of GitHub, it knows where I can push it back to. So I'll do commit and push. Then just hit push here. And if it asks you if you want to look at any reports or something, just say no. Because sometimes it'll have like a push report. So it says push successful. Go back over here to GitHub. I'll just hit refresh real quick. Probably didn't have to. I'll go into app. I'll go into source. I'll go into main. I'll go into my template folder. Here's my main activity. And you see my LOL comment is now there. I checked it out and I made a change and I committed that change back. Make sense? So your homework for Tuesday will be get that whole GitHub process working. I've given you this this Git template. All right, I'll put the link to it up there. So I want you to fork it, check it out, make a change. I'll probably tell you to put a certain comment in there or something like that, just like I just did there. Commit that change, push it back, submit your GitHub link, proving that you have GitHub working. Make sense? So if you get all your pieces working, the homework assignment shouldn't take more than 5 minutes. But this at least will introduce you to the whole process. Questions, comments, concerns, bribes? All right, I will see everybody on Tuesday. Have a good weekend. Is the hackathon a week from Saturday or is it 2 weeks from Saturday?
A week from Saturday.
A week from Saturday? So just as a reminder then, Monday night is our, if it's a week from Saturday, our hackathon, Monday night is a boot camp where we'll be introducing some VR stuff from 6 to 10 p.m. in this room. So if you're interested in kind of giving a kind of a quick crash course in some of the stuff we'll be working with in the hackathon, come on Monday night from 6 to 10. I will be recording it. So if you can't make it, I'll put the videos up. It's not required, but it might help you feel a little more comfortable to contribute to your group on Saturday. And also, if you have not emailed Professor Josh Locklear about the hackathon, do that as soon as possible, because like I said, you'll have a hard assignment if you don't do the hackathon itself.